gentlemen, welcome to America's Auto Enthusiast Program. This is Auto World. And now, here's your host, Bob Long.
Welcome, everybody. Thank you very much for joining me here for another edition of Auto World, and particularly for this hour of Auto World. And we always have a very special guest joining us. He is an expert, and we'll introduce him momentarily. But first, just want to salute the folks at Hagerty. If you need classic car insurance, only Hagerty has the expertise and the passion to protect your car how it deserves. Quote at Hagerty.com or with your local agent. Hagerty, for people who love cars. Sliding up to the microphone is our official lubrication specialist with more than 25 years of experience. He is one of the leading distributors of Amsoil all across North America. It's my pleasure to welcome the man behind the lubepage.com, the CEO himself, Dan Watson. How you doing, Dan?
I'm doing good, Pop. Great to be on the radio with you again.
Absolutely. It's always fun to get on here, and we got a lot of questions, and hearing from some of our great affiliate stations, which always makes me happy when I see that you get an email from someplace that I recognize, and we're on a great radio station. I should have a printout in front of me in Corpus Christi, Texas, and Pedro from Corpus Christi, Texas, writes, why do I have to run a slip lock additive in my positive traction rear end, the PosiTrack?
Well, I guess it would take just a minute, Bob. As you know, being familiar with cars, you can get these options in a lot of cars. You get a positive traction rear end, and what does that really mean? So I'll touch on that first and then explain the slip lock additive. But for folks out there that aren't really familiar with the exact terminology, in a positive traction rear end, it means that both wheels are going to pull evenly, when you start off straight from a dead stop and take off. If you were to spin the wheels, both wheels would break loose and spin. Now, in a regular type of rear end, it's got the right wheel is usually the power drive wheel, and the left wheel doesn't really turn unless, for some reason, the right wheel were to, let's say, not be able to turn. You could shift and get some power out of the left wheel. But this is designed specifically because when you turn a corner, everybody go back to their basic geometry class, you're making two circles with those rear wheels. Well, the inside circle is smaller than the outside circle in its circumference. So what that means is that the inside wheel wouldn't have to turn over as many times if you made a 360-degree turn, went out to a parking lot, and just turned your steering wheel and made a complete 360-degree turn. The inside wheel would not travel near the distance of the outside wheel to make that 360-degree turn. So if you don't have some way to compensate or work with this, you would end up with the inside wheel would have to basically skip a few times, sort of skip across the pavement in order to let the outside wheel continue to turn more. So what happens is that they design cars typically with just the one wheel so that if you turn either direction, they're not locked together and they can turn at different speeds. Now, when you have a positive traction rear end, you put two clutch packs back there. Yeah, that's right, clutches. When the axle comes out of the differential to go to the wheel, there is a clutch pack that connects the axle to the actual ring gear that is being turned by the pinion gear, which turns that axle. So it's not direct. It's going through a clutch pack. Now, why would they do that? Well, because when going straight ahead, the clutches are engaged. You've got enough of a clutch engagement that it's going to give you full traction, both wheels tearing out, taking off. But when you turn a corner, the idea is that inside clutch pack on the inside wheel will actually have some slip in it so that wheel does not have to travel the same distance as the outside wheel going around the circle or the curve. Now, people that have these know that when you have a problem and you make a turn, you'll get this skipping motion by the inside tire, and that reflects that they've got a problem. And that problem is the clutch on that inside tire is not slipping enough to make the turn without hopping around the turn. So that brings us to what is slip lock. Slip lock is the name that is used by a lot of people. Other people just call it, an additive, a rear end additive. But slip lock is the most name it's known by most. And what that is a type of lubricant that goes into the gear lube in the rear end so that it will get into the face of those clutches, and you will be assured that when you turn the corner that it will, in fact, that inside clutch will, in fact, slip the way that you want it to so that you can get around the corner. So when you make a corner with positive traction rear end and the inside tire is hopping or skipping, that tells you that you need slip lock additive in the rear end. So there's just no way around it. You've got to have some type of additional, because regular gear lube tends to not have that much of a friction modifier that you can slip that clutch. So does that make sense, Bob?
It sure does, and very important information. Let's go to a question you received from Atlanta on WCFO. Tom wants to know, how can Amsoil recommend up to 25,000 miles for an oil change?
Boy, Tom, you're not the only guy asking that question. That has been a question going on since 1971 when Amsoil first started. And then, as you recall, in the mid-'70s, Mobil came out with an oil that they recommended for 25,000-mile oil changes. So Amsoil's not, the strange oddball in the wilderness. I mean, there was other people that knew how to do this also. But when you have any oil, it doesn't matter what it is, okay? There's certain criteria for whether that oil is suitable for continued use. We call those condemnation limits, things that happen to the oil that may propose such a problem that it can no longer do its lubricating quality that you want it to do. And in internal combustion engines, we also have to take into consideration all these byproducts from that combustion that are going to get into the oil and what they do to the oil. So you have to start out understanding how oils are formulated. So this question can get really in the weeds if we let it. I mean, we can dig down into where we're just going crazy here, and nobody out in the listening audience has any idea what we're talking about, okay? But here's the basics. Whatever I use as the base stock, meaning my oil I start with, and I haven't put any kind of additives into it, I just got this oil there, I am going to have to determine how well that oil, for example, petroleum or synthetic, or what we refer to a lot of times as a very highly purified oil from petroleum side. If I start with one of these, what is its weakness? What would condemn this stuff if I went with it for an extended long period of time? I mean, what would happen to it that would force me to say this oil's no good? I hear the music starting in the background. That's a good thing. Maybe we can get into this in full detail after the break.
That sounds like a great idea. And anybody with any questions, 855-660-4261, Dan Watson at thelubepage.com, Bob at autoworldradio.com.
Giving your radio a broadcasted tune-up. This is Auto World and your host, Bob Long.
We're live on the coast of North America. Thanks for being here. My name is Bob Long, alongside Dan Watson, CEO of thelubepage.com, on the Haggerty-powered guest lines. And we're talking about some questions that have come in over the past week or so, and we're fielding one from a gentleman in Atlanta, and John has some doubts about the mileage capability, the engine oil life mileage capability. And Dan, you started to do a great job of setting the stage for this.
Yes, this question, like I said, can get it. Well, goodness, I've written, a few thousand-word articles on this, several thousand words. But here's the thing: I'm going to have this liquid, this base stock that I'm going to start with. That could be synthetic or petroleum. Now, I put additives in this, and people say, "Well, why do you have to put additives in the oil? Why don't you just go on with the oil?" Well, listen. Additives tailor the oil for the application that it will be used in. I put different additives in compressor oil than I put in automotive engine oil. I put different additives in diesel oil than I put in gasoline engine oil. Why? Because the byproducts of combustion that take place in gasoline and diesel are different, and I have to make sure that the oil can withstand the acids and the contaminants that are produced by that particular internal combustion engine over a period of time. So I put additives in for anti-wear, anti-foaming, antioxidants, and also, as I said, anti-acid or alkaline additives. And then I have this base stock of oil. So if I'm going to put together a formulated oil, and I'm going to recommend it to go for a certain number of miles or hours of operation, I got to know what would condemn that oil, what would make that oil bad. For example, if I go out and buy a tire, I look at the tire, and when the tire gets down to the wear indicators in the tread, I know the tire is used. It's over. I got to go get another tire. Okay? So how do I know when the oil is actually depleted and I got to go change it and get other oil? Those would be the factors, the condemnation factors that I would look at to determine, is there anything I can do to extend the life of this oil formulation? Same thing with the tire. How could I make the tire last longer till it gets down to the wear indicators? By making a heavier grade of tread, higher level. It could wear longer until it gets down, those kind of things. So I come over to the oil, and I got to figure out, gosh, what would kill this oil? Well, oil that thickens outside of more than one grade is actually the formula. If you had a 30 weight, it goes to a 40 weight, you don't have to condemn it. But if it gets to a 50 weight, that's a condemnation limit. On the other end, if I start out with a 30 weight oil and it thins to a 20 weight oil, that's a condemnation limit. I don't go down 2. I can go up 2, but only down 1. So all of a sudden I'm going, well, what would cause this oil to thin out, for goodness sake? Well, probably fuel contamination. So if I have heavy fuel contamination that, in a sense, the old term we use, waters my oil down or dilutes it down to where it's too thin, then gosh, I got to drain it out. Now, folks, there's nothing in the world that you can do to formulate an oil to make it withstand heavy fuel contamination. You get enough fuel contamination to lower it from a 30 to a 20, you better figure out whether you got fuel injectors that are bad, a carburetor that's bad. Why are you putting liquid gas or diesel into your engine oil? That has to be fixed from a mechanical status. You can't formulate oil to run around with high levels of fuel in it. Now, you can formulate it to handle some fuel, okay? So you don't want it to thin. Then we get to the real McCoy. What causes oil to thicken? Well, you can have an evaporation in oil, and if you have that evaporation or vaporization, believe it or not, inside that oil that you get out of the ground and you really clean it up, it has just a multitude of different size molecules. Well, as you might imagine, the little lightweight ones will boil off real easy, just leaves the bigger, heavier ones. That means your oil gets thicker due to vaporization. The other part is that if oil, if oil reacts with oxygen, it makes something we're pretty familiar with. It's called sludge. And if it can also make varnish under certain conditions. Now, Oil can also be beat up by the combustion process with the byproducts of combustion, nitrous oxide, turning oil into a thicker commodity than what you started with, okay, due to the nitrous oxides that can mix with the oil. Also, any of these things can turn into acids, and the acids can deplete an additive we have in the oil, which is designed to keep it from becoming acidic. If your oil becomes acidic, it'll just eat the face right off of the bearings, okay? So can't have that. So we got these things, we say, wow, these are condemnation limits. How do we adjust making this oil so that we can go more than, say, 3,000 miles? Because we've been making this other stuff and running 3,000-mile recommendations, and now even high-quality petroleum oils, they're saying they're recommending they can go 5,000, 6,000 miles. So what are we doing different? Well, number one, we're trying to get a better cut, that molecular structure, so that we don't have as many disparities there between tiny molecules and big molecules, so we can kind of cut down the vaporization so that it doesn't thicken so bad. Now, in a high-quality synthetic like the one sold by Amsoil Synthetics, it's uniform molecular structure to the position to where they're all the same size and vaporization is really low. So you're not going to thicken up in that Amsoil Synthetic due to vaporization. Then we go to oxygen. How can you protect this? Well, we put antioxidants into the oil. We pour this chemical in there and says, hey, bud, if oxygen gets into here through the air, naturally, these antioxidants are going to sacrifice themselves fighting these horrendous oxygen atoms. They're just going to, fall on their sword to protect the rest of the guys. But that only lasts so long before you run out of them. You run out of them, and the oxygenation starts to hit really hard. The oil will thicken quickly. So you got to know how long it'll last with those additives. Now, again, go to that high-quality synthetic that Amsoil sells, and it is inert. It's neutral, inert. It will not react with oxygen, the base stock. The polyalpha olefins that are put in, CAOs, they will not react with oxygen. So you don't have to worry about that. It's pretty much stable. Now, you may put in some antioxidants to assist that if you get to very high elevated temperatures, that it would continue to protect it. But basically, it's inert. So, hey, don't have to worry too much about that oxidation. Then you look at things like, what about the anti-wear additives? Well, that's up to the manufacturer. If you're going to recommend running this thing for 25,000 miles, you have to put a robust amount of anti-wear additives into the oil. Now, if I make an oil and I'm going to sell it with no more than a 5,000-mile change interval, I am not going to waste a lot of money putting extra anti-wear additives in that oil so they can go just a minimum of 5,000 miles. I told you, Bob, this would be a little more complicated. We'll have to finish it up after the break.
That's what we'll do. More with the professor himself, Dan Watson, straight ahead on Auto World.
East of the highway, hot sparks burning the night away. Two lips touching together.
Hi, this is Jay Leno, and you're listening to Auto World with Bob Long.
Watch out, man, how you drive that Cadillac there.
Thank you very much for joining me. I'm telling you. The name of the program is Auto World. And every week at this very same time, on this very same radio station, this is the time to get your oil questions asked. We've got the hood open here at Auto World, and we're finishing up a question from Tom in Atlanta. And Tom's original question was, how can Amsoil recommend up to 25,000 miles for an oil change? And Dan Watson from thelubepage.com is giving us not just a little bit of explanation, but the real deal.
Well, Bob, I'm going to try to sum it up here as I don't want to get further into the weeds on this. By the way, folks, at thelubepage.com, there's a series of magazine articles that I have written, and they go over this information in great detail. And you can see it, you can read them. One of them that's particularly good towards this is synthetic versus petroleum, why synthetic outperforms petroleum. Now, in general, what we've got here is a base stock that if it's a high-quality synthetic that you get from Amsoil, true chemical-based synthetic, what happens is it resists some of the things that kill oil, which is oxidation and vaporization. You get that out of the way, now we're going to worry about the additives we put in and whether they can last or go the distance. And so what Amsoil does is they put probably the most robust additive package you can put in an oil formulation and still have really an oil formulation without getting into something else. So enhanced anti-wear additives, the best you can buy. These oils, by their very nature, they don't require an excessive amount of what's called viscosity improvers. Viscosity improvers allow you to have multi-grade oil that goes to 5W40 or even 5W50, these kind of wide ranges. Well, a regular liquid can't do that, so you have to do certain things, the way you enhance it, the way that liquid responds to temperature changes to get it to where it can be a 5W and at 212 degrees be as much as a 50 weight. So these are things you do chemically, but when you use a high-grade synthetic base stock can match up with what's called a 5W and a 30 weight with zero additive. It can do that. So you don't have to put much of these viscosity improvers in. When you really have to jack up the viscosity improvers in petroleum in order to get that oil to be able to have a span of, say, 5W40, those viscosity improvers, even though they're vastly improved over what they used to be, if you're going to try to run that oil with that amount of viscosity improvers in it to go 25,000 miles, it may suffer what's called shear back and no longer be able to reach a 40 weight oil by the time it would try to get out to that distance. And so it just doesn't work. So to get these long drain interval oils, you have to have a high quality synthetic base. You have to put the right amount, sufficient amount of additives to cover antioxidant, anti-wear, anti-foaming, and your oil has to go the distance and not become acidic. You have to have a high enough total base number. So this is how you formulate this oil, and it's not magic. Really, it's just straight chemistry and understanding of oil. And so Amsoil started this in 1971 with the 25,000-mile oil. They're still selling 25,000-mile oils in 2018. It would occur to most people that if what you said wasn't true and wouldn't work, you wouldn't have gone from a 500-square-foot facility to a 1 million square foot facility if what you did didn't work. It's worked. It's proven to work. The company's success has been just outrageous. And other companies have now begun to try to follow suit and catch up in the synthetic world because synthetic oils are the future. They're here. They're not going away. They are the future of lubrication. You go buy a Toyota, it's bumper to bumper synthetic, has been for the last 5 years. Nothing's going to change. They're all heading towards that because they want thinner oil in higher powered engines. You can't do it with simple petroleum. That's like asking yourself to use a cotton line to catch 200-pound fish. You can't do it. You got to move on and use what works and what's been manufactured by the chemists and the people that work in this direction. So I hope that answers Tom's question. Listen, really, folks, if you're listening to this broadcast, go to thelubepage.com. These things are written out, and most people tell me I wrote them in such a way that the layman can understand them, and I didn't go into, lots of any kind of chemical formulas and all this stuff. So you'll find really good information that you can understand at the Lube Page and begin to understand this whole regimen of oil and lubrication. It's a fascinating part of the industry, but understanding it from a layman's point of view is not that difficult. Just go read those articles. I think you're going to really find that they'll give you some inside information. So, Bob, what's our next question?
Our next question comes from WCCM in Salem, Massachusetts. If petroleum oil is highly refined and has the correct additives, why can't you extend the oil change to as long as the synthetic oil? So it ties into the previous question.
And I could be like one of those guys, that, what was it, used to be on Seinfeld or something. I could say ditto, because we just really answered that question. I didn't realize that, but whole thing, when you have petroleum engine oils, they're fine for the limits that they have. They just can do the best they can under the limits that they have. And what we're forcing this whole lubrication regimen into with our modern cars, we want to use thinner oil and we want to go to higher temperatures. That's like the perfect storm to destroy most petroleum oil. So we have to figure out how we're going to do this, and, well, how we do it is we save ourselves with high-quality synthetics so that we can go thinner. And as we talked in a previous show, they got 0W16 coming over from Japan now. Any 0W16 has to be really high-quality synthetic, or else it's just never going to make the grade. And they know that, so they're pushing everything towards synthetic engine oils with low drag, high fuel economy, excellent protection, and you can only achieve that with thin oils with good synthetic base stock. So we'll just move on to question number 4.
And question number 4 comes from our great affiliate in Lakeland, Florida. I have a question here from Manny. I have a 2003 Ford Powerstroke Diesel and a 2017 Ford Powerstroke Diesel. Can I run the same diesel oil in both?
Well, it's a good question. And this is, this whole diesel community, since 2000, we've just been going in a lot of directions because they're being kind of beat up from the EPA and, pollution controls, because diesels, even if you took everything and didn't worry about it, except for they produce very fine soot that can go into the air, and that soot is one of the things that over the years the medical community tells us that it really messes up people with asthma and other breathing difficulties. This very, very fine soot can get lodged in the lungs of people. So a number of years ago, about 2007 approximately, the diesel manufacturers were required by regulation to put some type of soot filter in the exhaust system. So they put in what we refer to as a DPF, a diesel particulate filter in the exhaust system. Now that seems like a pretty straightforward thing, but folks, if you think about that, I hear the music again, so why start until we come back?
That's right. It only makes sense. More with Dan Watson. Don't forget, Dan Watson at thelubepage.com. Check out his YouTube videos as well. I'm Bob Long. Don't go away. We're coming right back.
Don't be confused. The way is clear.
My pappy said, son, you're going to drive me to drinking if you don't stop driving that hot rod Lincoln.
Giving your radio a broadcasted tune-up. This is Auto World and your host, Bob Long.
Have you heard the story of the hot rod race with the Fords and Lincolns was set in pace? That story is true. I'm here to say I was driving that
Auto World, as we do each and every week in this hour, where we've opened the hood and we've invited our go-to guy, Dan Watson, CEO of thelubepage.com, to give us some tips and to tell all of us, because I learn something from Dan every week about oil and about Amsoil. And right now we're talking about a listener in Florida with a 2003 Ford Powerstroke Diesel and a 2017 Ford Powerstroke Diesel. And he wants to know, can he run the same diesel oil in both? Ford is actually going to come out with a V6 diesel for 2018 as well, so there'll be even more in the mix.
Yeah, that's beautiful music to my ears. I'm a real diesel guy, looking at the performance of diesels and how well they do, especially turbo diesels. And when you get down to small turbo diesels, I know, even though Volkswagen, shot themselves in the foot with some of their shenanigans, but still, you drive around in a Volkswagen turbo diesel and you get anywhere, depending upon the vehicle and how you drive it, from say 42 to 48 miles per gallon, and anybody that has one of those little cars will tell you that when you step on it and the turbo kicks in, you think you got yourself a little rocket there. It takes off. So diesel engines are powerful. They utilize the fuel to a greater extent. There's more actual energy density within diesel than there is in gasoline, that you can extract a little more energy out of it. And due to the high compression in the engines, you get more power and you get great low-end torque in diesel engines. So they're a terrific engine. I think that where they really missed the grade is they wanted to make a real true hybrid, put a small turbo diesel in a hybrid with an electric hybrid system and see if you can't stretch yourself out to 100 miles per gallon without much trouble. But anyway, I'm off subject here. Talking about these two Ford Powerstrokes. The first one in 2003 did not have a diesel particulate filter. 2007, they started putting the diesel particulate filter in the exhaust. Well, I can put this fine filter in the exhaust. Anybody can imagine you can put a filter in like an air duct, okay? Think of your air conditioning unit at home. Put the filter in, you run it so long it gets clogged up. What do? You go in, you take that filter out, throw it away, and you put another one on. Well, that's not practical with a diesel particulate filter. It's a welded-in portion of your exhaust.
Sure.
So the question was, how am I going to clean all this carbon out of this filter that I've collected, this fine soot that I've collected on the substrate in this filter? How am I going to clean this stuff out? Well, they figured out that you can actually burn that carbon up, okay? But you're going to have to create basically a fire inside this diesel particulate filter that burns all this residual carbon out and gives you a clean filter to start over again. Well, how are you going to do that? Well, I got something to do it with. I already have a tank full of diesel. How can I put some diesel in that filter so that it will basically catch on fire and burn up all of that fine soot, give me a clean start, and we'll go again? That's called a regeneration cycle when that's done. So in that older vehicle, that 2003, none of this had to take place. But in the newer vehicle, we got very sophisticated about how we do it. And so this exhaust change in this diesel exhaust system created in 2007 that I needed to reformulate the oil to be different, because I'm going to ask the oil to absorb a lot of soot, and that oil is going to have to actually perform in a lot of areas at a higher level than it did for the 2003 vehicle. So we came out with a revision, and it was called CJ4 instead of CI4 Plus, which was in the 2003. So we had a modification, and we went a few years, and then we modified the exhaust again. And we put this urea tank in the exhaust. Okay, folks out there, I know it aggravates you if you have urea tank. I got to buy this stuff, got to pour it in the urea tank. You pat that urea tank on your diesel and say thank you very much, because it has changed the way we get that diesel back in. Well, not in all of them. In some, it changed the way they put the diesel back, but what it did mostly was it reduced the amount of exhaust gas recirculation in that diesel engine, which was just choking it down. So if you have a urea tank, the EGR has been really lowered. Your engine can run now with more power, more efficiency, and greater fuel economy than the ones that had a DPF but did not have a urea tank. You guys out there with the diesels, you know what I'm talking about here. You understand this lingo. It's a little bit complex for other people, but in 2017, came out with the next version of diesel oil, which is called CK4. Now, the CK4 made some improvements from the CJ4 to make a better formula to deal with all these exhaust situations in these diesel engines, okay? So CK4 is the current rating, and that CK4 is backward compatible. It will, in fact, substitute for the CI4 Plus that you used in the 2003. Now, that being said, if you have a 2003 Powerstroke, and you can still get genuine CI4 Plus rated oil that does not carry either CJ4 or CK4, that's what I would recommend to you if it were my 2003 Powerstroke. And why? Because that oil that was made for the 2003, the CI4 Plus heavy-duty diesel oil, has a larger or greater amount of zinc and phosphorus in it than the newer ones. Because, see, in 2007, they also put catalytic converters in. So we now have a particulate filter, a catalytic converter, and a urea reaction tank in what they call the SCR exhaust systems on these trucks. See, stuff has gotten so complicated. But that older truck didn't have any of that. So the CI4 Plus was a very heavy-duty, highly additized engine oil made for those applications. And so in the Amsoil world, we continue to sell an oil that many, many diesel owners are familiar with. It's called Amsoil's heavy-duty diesel and marine engine oil. And it is a CI4 Plus heavy-duty fleet quality oil. It's rated as a marine engine oil because it has actual chemical rust inhibitor to make it better at rust control than the average oil. So we still sell that because people still demand it, and they buy tons of it. But if you go out to the auto parts store and you look for a CI4 Plus oil, what you're going to find is that it's going to list CI4 Plus, CJ4, and CK4, and it's going to say that those are all met by that requirement. Now, what you need to understand is that both the CJ4 and the CK4 have limits on the amount of zinc and phosphorus they can have in those oils in order to protect from any carryover that could damage the catalytic converter. So if you run that in your older engine, that's fine. It is compatible. It will run. It just doesn't have as much zinc and phosphorus in it as that older formula had for that older Powerstroke engine. So I would continue to run that, but you're not going to be able to find CI4 Plus by itself, that's the maximum rating that the oil carries in many places. But if you're looking for a high-quality synthetic that is still limited to CI4 Plus rating, Amsoil carries that. It's called heavy-duty diesel and marine engine oil. Excellent oil for those diesels. Now, coming forward, the new Amsoil Max Protection diesel oil that is CK4 rated, it's unbelievable. I mean, this is where you could use CK4 to cover the CI4 Plus and not be worried about it, because in this Amsoil Max Protection oil, you just have to read the information on it. It has 6 times the protection quality by a Detroit measurement, Detroit diesel measurement that was created as a standard, and that standard, let's say, is 1. Well, Amsoil would be a 6. It has 6 times the protection that's required by the standard in this Max Protection oil. It is the most amazing formula they've come out with yet, and you just can't beat it. It is bulletproof, incredible formulation that's been put together, and it's one of the best oils that Amsoil's ever produced, and it's in their new CK4-rated diesel engine oil. So I know I spent a little extra time on that, but if you really want to know something about that diesel particulate filter, go to YouTube, type in Dan Watson, look at my YouTubes that are available, and you'll find one that has been viewed thousands and thousands of times. It's about the diesel particulate filter system. That's it for me, Dan Watson.
Great job as usual, my friend. Talk with you next week, same time, same place. Email up your questions, bob@autoworldradio.com or Dan Watson at thelubepage.com. Thank you very much for coming along for the ride. Folks, this is Bob Long, host of Auto World Radio, with great news. We have a new sponsor, Dan Watson, who distributes Amsoil throughout the USA and Canada. Dan is one of Amsoil's largest distributors. He's a former U.S. Navy nuclear specialist and a certified lubrication specialist with 25-plus years of experience. You can listen to Dan every Sunday evening live at 6 p.m. Eastern Time here on GCNlive.com. Get all of your questions answered and ensure you get the best lubrication for your car, truck, boat, or really anything that moves. In 1972, Amsoil pioneered synthetic lubrication, and Amsoil continues to provide the best lubrication money can buy. Get the best advice for the best results. Contact Dan at thelubepage.com. That's thelubepage.com, or call 800-370-2986. That's 800-370-2986.